All right, so here we're going to look at generating equivalent expressions. And so there's a couple different ways that you can do this. Are 6 times the quantity n plus 3 minus 4 and 6n plus 14 equivalent expressions. So first you could take like this expression and you kind of combine, like distribute the 6 and combine like terms. So you do 6 times n plus 3 minus 4. Let me close that parentheses. So then I would distribute the 6 to the n, and 6 to the 3. 6 times 3, or 6 times n is 6n, plus 6 times 3 is 18, and then minus 4. And now I can combine the 18 and the 4. 18 minus 4 is 14. So you end up with 6n plus 14. And when you do that, you can see these are the same expression. So you could argue that in that case, they're equivalent. Another method we can use is called substitution. And in substitution, you pick a value for n. And when you do this, you don't want to use 0 because 0 is not a valid value. Basically, almost any expression can be equivalent if you use 0. So it's not a valid. You generally want to use more than 1. For this example, I'll use 3 first. So 3. So I'll come over here and I'm like 6 times n plus 3 minus 4, and I evaluate it when n is 3. So I'm doing 3 plus 3 minus 4, but first I have to multiply by 6. So order operations states, your hierarchy of operations states that you'll do your parentheses in here first, then you'll multiply and divide, and then you'll add and subtract. So I start up here, parentheses 3 plus 3, so that is 6. So I do 6 times 6, that's what these parentheses can indicate, multiplication. 6 times 6 is 36. All the meanwhile, I still have to subtract 4. Still have to subtract 4, so 36 minus 4 is 32. I did the same thing over here with this one. 6n plus 14. But this time I substitute in 3 here. So it's 6 times 3 plus 14. 6 times 3 equals 18. 18 plus 14 would be 8 plus 4 is 12. And then it'd be 1, 2, 3, so 32. So 32 and 32 are the same. So that would again prove that it's equivalent. You'd want to try and test another number. You could try and test 2. That'd be an easy number to test and make sure they're equivalent as well. Let's go on to the next slide. Oh, I did go on to the next slide. Aha. I'm on slide 2, slide 1. Okay. Slide 2, let me clear all my ink. Show the clock now. Erase. Wipe screen clear. There we go. Okay. Did not know that would happen when I went to change slides. Sorry about that. Okay. Are 2 times x minus 3 plus 1 and 2x plus 6 equivalent expressions? Use substitution to justify your work. So in this case, they just want us to substitute. So you would do 2 times x minus 3 plus 1, and then we could do 2x plus 6. Now, we don't want to use 0. 0 is not a valid substitute. So let's go ahead and use a number like, say, 1. 1's pretty easy to work with, right? So I do 2 times 1 minus 3. That's going to be a tough problem to work with, so you might want to start with a 3 instead, plus 1. 1 minus 3 is negative 2. So this isn't something we covered in class. So just FYI, because now we're going to have to multiply by that negative. So we probably want to avoid using 1. In this case, I'd be like, okay, I don't want to do that. So let's go back and use 3. 3 minus 3, that's going to be 0, times 2 plus 1, right? 3 minus 3 is 0, times 2 plus 1 is going to be 0 plus 1, and then it'll be 1. Over here, 2x plus 6. So if I put a 3 in here, 2 times 3 plus 6, 2 times 3 is 6, plus 6 is 12. So these don't look like they're equal. I might want to try 4 too, but I also want to try 0 just to show you why that wouldn't necessarily be valid here. So if I put a 0 in for x, and I put 0 minus 3 would be negative 3. And then 2 times negative 3 ends up being negative 6, plus 1 would be negative 5. 2 times 0 is 0 plus, so that these wouldn't work out to be equal even with 0. So even 0 does that, but 0 is not a valid substitute. So we could try 4 again, and they again wouldn't come up to be equal. So these are not equivalent expressions. Again, remember, number one thing I want to emphasize here, don't ever use 0 to substitute. Use a different number, not 0. If you use 0, you're probably going to get it wrong. Hint, hint, nudge, nudge. Remember this. Don't use 0 to substitute to prove that expressions are equivalent.